Welcome. Today we're going to talk about exponential functions, and we're going to graph exponential functions ultimately, and then identify, given a graph, equation, or table, we're going to identify whether or not a function is exponential or linear. But we're actually going to start with kind of like a warm-up to kind of preview and review things that we already know to get us ready for this lesson. So let's take a look at some graphing. So just plotting points on a coordinate plane. You've done this before, and some of these are going to be easy, but I want to really focus on things like this one here, where you might have like coordinates like 4 comma a third. We can still graph that point. You may have never done it before, but I'm going to show you how to do it now. All right, so we'll start with letter A, the point -3 comma -2. This is, your points are always x comma y, and this here is your x-axis and your y-axis. So the point -3, you count over 3 units in the y direction. So like 1, 2, 3. And then, 3 units in the x direction. I think I said y, excuse me. And then down 2 in the y direction, because both are negative. So this is the point -3 comma -2. So the point 4 comma 1/3. So we want to go over 4 units in the x direction. So 1, 2, 3, 4. And then we want to go up a third. Well, a third is, as a decimal, like 0.3. It's somewhere between 0 and 1, but way closer to 0. Now, I'm not going to be able to find this point exactly, but I'm just going to try and estimate it. So that's probably close enough. So this is the point 4 comma 1/3. Letter C, -2 comma 3/2. So we go over to the left. Let me kind of get rid of some of this here. All right, there we go. So we're going to start by going over to the left, -2, and then we're going to go up 3/2. Well, 3/2 is 1.5. So -2 comma 1.5 will be right about there. Again, I'm just kind of estimating when I have a non-whole number value. And then number 2, in what quadrant or on what axis would the following points fall? So quick review. This is quadrant 1, 2, 3, and 4. So the point -6 comma 0, I'll use another color for this. So the point -6 comma 0 means go -6 to the left and up or down 0. So this is -6 comma 0. So that's on the x-axis. Letter B, or letter E, really, the point -1.2 comma 4. So 1.2 is a little bit more than 1, and then up 1, 2, 3, 4 will be right about there. And so -1.2 comma 4, that's in the second quadrant. And the point 3 comma -8, that is down in the fourth quadrant. All right, so now that we know how to plot these points and think about what quadrants they're in, let's take a minute and plug in some x values into this equation and solve for y. So if you want to try this on your own, now's a great time to kind of pause this video. And then when you unpause, you can just check your answers. Or if you want to go through it with me, I'm going to go through each one of these. So let's start with the x value of -2. If I plug in -2 for x, I have y is equal to 5 to the -2. So I have this negative exponent. And what do negative exponents tell me to do? They tell me to flip the base. So the 5 is going to flip to the bottom of the fraction, and it becomes 5 to the positive second. I don't have anything left on the top, so I'm going to put a 1 up there. Now, I got to keep simplifying this. 5 to the positive second is 25. So when x is negative 2, y is equal to 1 over 25. Remember, a negative exponent does not make the number negative. It tells me to flip the base. Now I'm going to plug in negative 1. So y is equal to 5 to the negative 1. Again, a negative exponent tells me to flip the base. So this becomes 5 to the positive first on the bottom. Nothing's left on the top, so I put a 1. Well, 5 to the first is just 5. So this is going to be 1 over 5. All right, how about when I plug in 5 to the 0? When I plug in 0 for x. Anything to the 0 power we know is 1. So this is just 1. Now I have y equals 5 to the first. Well, 5 to the first power is just 5. And then finally, y equals 5 squared, which is 5 times 5. So y is equal to 25. So we're going to be filling out tables similar to these. And I don't want you to panic. We're just using our rules of exponents like we've already learned. Okay. So let's get into some definitions. You can write this down in your toolkit. So let's talk about linear versus exponential functions. And feel free to pause the video if you want to take a minute to write this down. But linear functions, when you look at graphs, they'll look like this. They graph a straight line. Now this line has like a positive slope. They don't necessarily always have to have a positive slope, but the important part is that the line is straight. As opposed to exponential functions that graph a curve looking like this. And again, not every exponential curve is going to be going up like this. You'll see as we go throughout this lesson what they're going to look like. Some will be going down, some will be going up. But in terms of the equations, linear functions, their equations are going to look like this. Y equals mx plus b. So notice you have an x and a y, and then the m and the b are going to be numbers. So these could look like y is equal to 5x plus 2. As opposed to exponential functions, look at this x here. This x is an exponent. So an exponential function might look like this. Y is equal to 3 times, let's say 7 to the x power. So the big key that you're looking for in an exponential function or equation is that x is an exponent. And then if you have a table of values, meaning kind of like the table of values that we just looked at, or that we just made, your table of values, if it's linear, you're going to look for a pattern in the y variable. So if that pattern shows addition or subtraction, meaning this might be like 7, 10, 13, 16. So I'm looking at the y column here. If that y column shows me an addition or subtraction pattern, notice I'm adding 3 every time there, then it's linear. As opposed to if my table shows a pattern like multiplication or division. So like, for example, I might start with the number 3, 6, 12, 24. So again, I'm looking not at the x's, I'm looking at the y's. See, I have that relationship where I'm multiplying by 2 every time. That tells me that the table, or that the relationship is exponential. Okay, so when you have this all written down, let's move on. First, let's take a look at some of these graphs. Which of the following functions are linear and which are exponential? So linear, they're going to give me a straight line. So I see that straight line here. I see that straight line here. And exponential functions are going to give me that curve. It's either going to kind of start low, like this one here. See how it starts low and then it curves and goes up? Or it's going to do the opposite. It'll kind of start high and curve down. And some of these curves are going to be like steeper than others, but all these are going to be exponential. And this top one up here, A. So those are all exponential. So looking at the graphs and identifying which is linear and exponential, that should be pretty simple. Okay, so now let's graph exponential functions. So this should look familiar. This looks very similar to the problem we did in the warm-up. But let's talk about it now. Now that we know what an exponential function is, we see that that x is an exponent. So this function is an exponential function. Let me go back to this warm-up that we did. Look, y equals 5 to the x. So that equation is exponential. And actually, let's look at this table that we made. This table that we made, these fractions, and I'm looking at the y values. This might be a little bit confusing. But look here, 1 to 5 to 25. What's the pattern? The pattern is that let me switch colors, sorry. I'm multiplying by 5 to get the next number. Multiply by 5 to get the next number. And even the fractions look a little bit confusing, but think about it. If I multiply by 5, 5 is 5 over 1, and that's 1 times 5, which is 5, over 5 times 1, which is 5, which equals 1. Even the 1 over 25, multiply it by 5. 1 over 5 is 5. 25 times 1, 25. Reduce that, you get 1/5. So you can see that this pattern is that I'm multiplying by 5 every time. So exponential equation, and then my table is exponential as well, right? Okay. So let's go back. We're going to graph this exponential function. Y is equal to 3 to the x. So we're going to plug in these values just like we did before. Y equals 3 to the negative 2. Negative exponents tell me to flip the base. So this is going to be 3 to the positive second. I don't have anything left on the top, so I put a 1. And 3 squared is 9. So this is 1 over 9. When x is negative 1, again, this does not make the number negative. It tells me to flip the base. Negative exponents tell me to flip the base. So this becomes 3 to the positive 1. Put a 1 at the top. 3 to the first is just 1 over 3. Now we're going to plug in 0. 3 to the 0 is 1. Next, we're plugging in 1 for x. 3 to the first is just 3. And then finally, we're plugging in 2 for x. So 3 squared is 9. So look at this table at the y values again. These y values, what's the pattern? hopefully you can see that the pattern is that with every next y value, I'm multiplying the previous y value by 3. All right, so we can make the table of values now. Let's graph these points. So we have the point -2, 1/9. Well, that's why this is why we practiced plotting points before that aren't whole number values. So the point -2, we go over -2 in the x direction. 1/9, use your calculator. Remember, fraction is really division. This is really 1 divided by 9. So 1 divided by 9 is 0.111. So go over -2, go up 0.1. We're like right about there. -1, 1/3. 1/3 might be just a little bit higher because it's like 0.3. These aren't exact values. I'm getting as close as I can. The point 0, 1, that one's a little easier to graph. 1, 3, and 2, 9. So you can see when I plot these points, I'm starting to see that like curved look. Now watch, when we connect these, any exponential function is going to kind of level out. So when you connect them, your graph is going to look like this. It's going to almost kind of start looking like straight. And then it's going to go up, and curve and go up almost like straight there. So that's what your exponential function is going to look like. Here's what I don't want you to do. A lot of people start and go like this. They start down here. It won't have that steep slope down there. Don't do that. You want it to kind of, like you see in the red, you want it to kind of like flatten out here at the bottom, okay? So I'm going to erase that blue. Okay. So there's our exponential graph. So you can see the original equation had the x as the exponent. It gave us a table that showed multiplication. And then when we graphed it, it had that curve that we saw before in the notes. Okay. Pause the video now. You try this one. Plug in the x values, simplify for y, plot the points. And then when you unpause it, check your answer. Okay. So when I plug in these values, I'm just going to show you the negatives again, because I know these are the tricky ones. But the negative exponent tells me to flip, right? The fraction, the base, excuse me. So the base of 2 goes to the bottom. The exponent becomes positive. 2 squared is 4. So this is 1/4. When I plug in -1, the 2 flips to the bottom, the 1 becomes positive, this becomes 1/2. When we plug in 0, 2 to the 0 is 1. 2 to the first is just 2, and 2 squared is 4. So these are the values you should have gotten in your table. And then when we plot these points, again, don't be afraid of the fractions. 1/4 is 0.25. So -2, 0.25. -1, 1/2. I can't find these exactly. I'm just trying to get it like as close as possible. 0, 1, 1, 2, and 2, 4. So again, remember your exponential function kind of starts flat. It's going to curve up. And then it's going to kind of almost like flatten out again, right? Like almost like going straight up. So there we go. We have another exponential function. And I knew it was going to be exponential because the x was an exponent, right? In the original equation. Okay. Let's try this other one. The difference between this and the two that we just did, these two that we just did, the base, the 3, and the 2 are the bases. Those are whole numbers. Now, what if my base is a fraction? Let's look. So we're just going to plug in x values. So 1/2 to the -2nd power. Think of this as like a power to power. So I'm going to raise the 1 to a -2nd power and the 2 to a -2nd. So both of these things, both of these bases are going to flip. So this becomes 2 squared over 1 squared. Well, now 2 squared is 4. 1 squared is 1. So this actually is going to simplify to a 4, plain old 4. Okay. Now, what if I put in 1/2 to the negative 1? What if I plug in negative 1 for x? So power to power, this is going to be 1 to the negative 1 over 2 to the negative 1. So both bases are going to flip. So it becomes 2 to the 1 over 1 to the 1. 2 to the 1 is just 2. 1 to the 1 is just 1. And 2 over 1 is just 2. All right. So now what if I plug in 0? I know anything to the 0 power is 1. So the whole thing is raised to the 0 power. Or I could think of it as like a power to power again. 1 to the 0 over 2 to the 0. 1 to the 0 is 1. 2 to the 0 is 1. 1 over 1 is 1. But again, I wouldn't even do all that. This whole thing is raised to the 0 power, so it's just 1. All right, how about 1/2 to the first? So anything to the first power is just itself. Or I could think of it like 1 to the first over 2 to the first. So this is going to be 1/2. And now when I plug in 2 for x, I'm going to raise the top to the second power and the bottom to the second power. 1 squared is 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. Okay, so now I have this table of values. Let's plot the points. So we have the point -2, 4, which is up here. -1, 2. 0, 1. Then we have 1, 1/2. And finally 2, 1/4. Or in other words, like 0.25. So now you can kind of see I still have this curve, but over on the left, it actually starts at the top. So again, we're starting, it's like almost like straight down. And then it curves around and kind of flattens out in this direction. Again, it's flattening out. It's not like continuing to go straight down or anything. So now we see this like exponential graph, this curve, because again, it doesn't matter what my base is. My x is an exponent. In the y values, what's the pattern? Instead of multiplying by number, I'm now dividing. 1 divided by 2 is 1/2. 1/2 divided by 2 is now 1/4. So I can see this pattern where I'm dividing. And I still have this curved value. But now instead of my curve kind of going from left to right going up, from left to right, this one's going down. Okay. So why don't you pause the video here, try this one on your own, and then when you're finished, you can unpause and check your answers. Okay, let's check these answers. So I'm just going to go through the negatives with you because I know those are the tricky ones. So when I plug in those negative exponents, x is -2, so 1/3 to the -2. I think of this as being 1 to the -2 over 3 to the -2. Those negative exponents, they don't make the number negative, they make the bases flip. So it becomes 3 squared over 1 squared. 3 squared is 9. 1 squared is 1 times 1, which is 1. So that's 9. All right, how about this -1? When I plug in x is -1, so it'll be 1 to the -1 over 3 to the -1. The bases are both going to flip. Becomes 3 to the 1 over 1 to the 1. 3 to the 1 is 3. 1 to the 1 is 1, so this should just be a 3. Anything to the 0 power is just 1. when I raise 1/3 to the first, I just get 1/3, right? And 1/3 to the second is 1 squared over 3 squared, which is 1/9. So hopefully you got those same values. And again, notice x is the exponent. What's the pattern? I'm dividing by 3 every time, right? Okay, let's plot these points. -2, 9. -1, 3. 0, 1. 1, 1/3, which is like 0.3. 2, 1/9, which is like 0.1. And now we see this curved pattern. When we connect these, remember they're going to kind of flatten out again. And the other thing, not sure if I mentioned this before, but these kind of go on forever, just like lines. So hopefully you've noticed that I've been drawing arrows at the end of each of these graphs. All right, awesome. So that's a little bit about graphing. Let's talk now, go back and write this down in your toolkit, but let's talk now about exponential growth versus exponential decay. So now that we've looked at a bunch of exponential curves or graphs, hopefully you notice that some are increasing from left to right and some are decreasing or going down from left to right. So copy these down. If we have a curve that's exponential growth, it's like over here in the left in the green, it's increasing from left to right. So it starts like kind of flat, and then it curves up when we go from left to right. And you're going to have an exponential growth curve when the base is greater than 1. So in other words, your equation for an exponential is y is equal to a times b to the x. So in other words, this number, the base, has to be bigger than 1. So for example, y is equal to 7 to the x. Y is equal to, even if I have like -2 times 4 to the x. I don't care about that -2. The base is 4. And let's go back and look at the ones that we just graphed. This first one that we graphed, this is going up from left to right, so it's exponential growth. The base was the number 3. Again, exponential growth going up from left to right. The base is 2. Both of those values are bigger than 1. Let's look here. This base is 1/2. That value is less than 1. So we can see that we have exponential decay. From left to right, this curve is going down. The same with this one. The curve is going down from left to right. Well, the base was 1/3. So if the base is a number between 0 and 1, so for example, y is equal to 1/5 to the x, and it can be written as a fraction, or it could be a decimal. So like 0.75 to the x. And just like I did over here in the green, I could have a number like -5 times 0.3 to the x. I don't care about that -5. I only care about the thing that's being raised to the x power, which is that 0.3. And these are decreasing from left to right. So again, they should have arrows, but decreasing from left to right. All right, pause if you need to finish writing this all down. Okay, so let's go back to these graphs that we started with. We said that these are linear, right? And we said the other 4 are exponential. Are they exponential growth or exponential decay? So letter A, this one's going down from left to right, right? So this is exponential decay. Letter D, exponential growth. Letter E, exponential decay. because it's going down from left to right. It's less steep, but it's still going down. And this one is less steep too, but it's still going upwards. So it's exponential growth. So again, the graphs are pretty easy. Let's look at some equations. Let's identify these equations as linear exponential growth or exponential decay. So the key for exponential is that the x is an exponent. Looking at number 1, our x, that's what we're going to kind of locate first. Our x is not an exponent, so this one's linear. And this is just basically in the equation, or in the form y equals mx plus b. Number 2, the x, that's an exponent. So I know that this is going to be exponential. And then I think about the base. So the base, what's being raised to the x power is just that 3. 3 is bigger than 1. So this is exponential growth, meaning when I graph it, it's going to go up from left to right, right? All right, number 3, find the x. Remember, that's your key. So you're looking for the x. The x is an exponent, so it's exponential. And then you're looking for the base. What is being raised to the x power? Well, this means 3 times 0.7 to the x power. 0.7 is a number between 0 and 1. So this one is exponential decay. So remember, if the base is between 0 and 1, it's exponential decay. Number 4, the x is an exponent. So this is exponential, and this means y equals 2 times 4 to the x. So the base is the 4. That's the only thing being raised to the x power. So this is exponential growth, because 4 is bigger than 1. Number 5, find the x. It's exponential, and the base is 3 over 4. That's less than 1, so exponential decay. And finally, number 6, that x is not an exponent. This means 1/2 times x, not 1/2 to the x. So this one is linear. Okay. So now that we looked at some equations, we're going to finish off with looking at some tables. Remember, we said if the relationship in a table is linear, you're going to see a pattern of adding or subtracting. If it's exponential, you're going to see the pattern of multiplying or dividing. So let's look at a couple. And remember, when I say the pattern, I'm looking in the y, at the y values. So look at those y values. So take a minute and think about the pattern. What do you see? Well, 5 plus 2 is 7. Plus 2 again is 9. Plus 2 is 11. So the pattern here is that I'm adding 2. And because I'm adding 2, that tells me that the relationship is linear. So let me give you a piece of advice. You should be able to identify the pattern, tell me what the relationship is, and then tell me why the relationship is linear. So on a test or on the Keystone exam, you might say, the question might say, what type of a function is this? Linear, exponential, decay, or growth? And you would say, oh, it's linear because the pattern in the y values is that I'm adding 2 every time. Okay, so look at these y's. And I'm going to tell you, if you have fractions like these, kind of just focus on the whole numbers first. 25, 5, 1. What's the pattern? Now, at first I might think, oh, from 25 to 5, I can subtract 20, right? 25 minus 20 is 5. But if I subtract 20 from 5, I don't get 1. So hopefully you can see that instead the pattern is that I'm dividing by 5. And you know what? This is actually a typo. I'm sorry. This should be 1 over 5. Please change that. And this is 1 over 25. So Divide by 5, you get 1 over 5. Divide by 5 again, and you'll get 1 over 25. So this is exponential. And then, because you see dividing, you think about these values. Are they going up or are they going down? So 25, 5, 1. These are going down. So this one's exponential decay. And then in this third one here, number 3, again, look at the y's. The fractions, they might be a little confusing to you, so ignore them. Look at the whole number values. We start at 5, 15, 45. What's the pattern there? At first I might think, oh, 5 plus 10 is 15. But 15 plus 10 is 25. That can't be it. Well, how else can I get from 5 to 15? Oops, excuse me, sorry. I can multiply by 3. 5 times 3 is 15. Oh, 15 times 3 is 45. And you can check here. If I multiply 5 over 3 times 3, 15 over 3, which is 5. And you can check 5 over 9 times 3, I meant to write. 5 over 9 times 3 again is 5 over 3. So this one is exponential because the relationship is multiplying. And then think about, are those y values going up or down? They're going up, so we're going to call that exponential growth. Okay. So we're going to finish off by just a little bit more identifying from a table whether we have linear, exponential growth, or exponential decay. Pause the video, try these, and then when you come back, we'll go through these. You can check your answers. Okay, so let's look. Number 1, these y values, remember we're looking at the pattern in the y's. These y values are actually decreasing every time by 3. So because the pattern is subtracting, we call that linear. Number 2, hopefully you saw that the pattern is multiplying by 5. So because we're multiplying, it's exponential, and these numbers are getting bigger. So it's exponential growth. All right, number 3, the pattern multiplying by 3. The numbers are getting bigger. So exponential growth. And then number 4, this might be a little tricky, but I would start by saying like, oh, how can I get from 10 to 1? From 10 to 1, I could subtract 9. But subtracting 9 would give me -8, not 1/10, right? So let's use multiplication or division. I'd have to divide by 10 to get 1. Divide by 10, 1 over 10. There we go. So this one is exponential decay because they're getting smaller. And then number 5, again, it might feel tricky with like the negative values, but hopefully you saw that the pattern was we're adding 2. Adding 2 every time. So that's linear. All right, that's it.